I'm going to continue on our discussion of converting to algebra. I'd like to just go over this problem. It's a little more advanced than our last problem that I went over. It's what I would call a mixture problem because we are mixing liquids together. So we call it a mixture. So read through this. This is page 361 in case the video quality is not good enough to read this, but I'll read through it really quickly. Augustus is trying to make a chocolate milk. He has a 10% chocolate milk solution, which means that 10% is chocolate and 90% is milk. He has also made a 25% chocolate milk solution, so 25% is chocolate and 75% is milk. Unfortunately, the 10% solution is too weak and the 25% solution is too chocolatey. He has a lot of the 10% solution, but he only has 30 gallons of the 25% solution. So to weaken this up, we're gonna pour some of this 10% solution into the 25% solution. So when this says he has a whole lot of the 10% solution, that means we can just keep pouring and pouring and pouring as much as we need to. All right, how many gallons of the 10% solution should he add to that 25% solution, of which he has 30 gallons, to make a mixture that is 15% chocolate? All right, so let's go through this. First of all, let me set it up as a guess and check chart because that's the way we were going. If we are pouring in the 10% solution, let's make that our guess. How much? And we're dealing with gallons, so we call this gallons of 10% solution. Alright, so let's make a quick guess here. What if we guessed he was going to pour in, how about 20 gallons? Alright, well, if we knew that, and we knew that it's a 10% solution, then we should be able to figure out how many gallons of chocolate are in that 20 gallon amount that we've poured in. So let's call this gallons of chocolate in that 10% solution that we put in. Well, this is just, let me write it small up here, but this is just 10%, which I'm going to write as 0.10, times the amount. So use your calculator if you have some more challenging decimals to work with, but this ends up being 2 gallons. Alright, that's the gallons of chocolate that we're pouring in. Now, we can also figure out, and this is going to be constant, we also know how many gallons of the 25% solution we have. So I'll just write gallons of 25% solution, and that's 30. We always have 30 gallons. And so we always have, in that 25% solution, we always have the same amount of chocolate in the 25% solution. So these two columns are going to stay constant. Alright, and if you want to figure that out, come over to the side somewhere and say, alright, well, 25%, which is 0.25, times the 30 gallons, plug that into your calculator and you get 7.5. So we have 7.5 gallons. I don't need that decimal there. 7.5, there's my decimal. 7.5 gallons. Alright, now what I'm trying to get to is a 15% chocolate solution. So if I've poured all this together, think about how much chocolate you have in total. Total gallons of chocolate. And of course, this is just the 2 gallons of chocolate from the 10% and the 7.5 gallons of the 25%. So that's going to be 9.5 gallons. And then how much liquid altogether do we have? Well, let me call this total gallons of the mix. And that's the 30 gallons of the 25% solution that we're starting with, and the 20 gallons of the 10% that we're adding in there. So this is 50 gallons. All right, now we want to figure out what's the percent of the chocolate mix. And to do that, I'm just going to take the amount of chocolate divided by the total amount of liquid. And in this case, that gets you exactly 19%, or 0.19. So remember, we're going for a 15%. So this looks a little high. I'd come over here and do my rate column if this was a guess and check problem. And I'd say high, and I'm going to put a question mark there because maybe it's not. So let me come down and pick another number that's lower. And really all I'm doing, because I'm going to convert this to algebra, I'm just getting the hang of what's going on in my guess and check table. I highly recommend doing 2, and then if you're still struggling, 3 or more, until you get the hang of exactly what you're doing in each column. So pick easy numbers. I'm going to pick 10, because that means 0.1 times 10 gives me 1 gallon of chocolate that I'm adding in. So I've added 10 gallons of the 10% solution. That means one of those gallons must be the chocolate and the other 9 must be the milk. All right, these gallons stay the same because I always have the 30 gallons of the 25% solution. So I don't have to figure those out again. And now remember, to get the total gallons of chocolate, I added the second column here plus the gallons of chocolate from the 25% solution, so this is going to be 8.5. And now for the total gallons of the mix, that's the total gallons of liquid I have. So that's the 10 gallons I threw in to the already 30 gallons. So now I have 40 gallons. So this time I'm going to take 8.5 and divide by 40. And that gets me, looks like it's going up, 0.2125. So if this were a guess and check, I'd come back here and say, nope, this was low, this was lower. So then I'd guess something higher than 20, like maybe 30. But I feel like I've got the hang of what's going on in my chart. So now I'm going to jump to figuring out what the equation is and solve that. So I'm converting this to algebra now. So I'm going to use G for my variable. G is standing for gallons. All right. Then what did I do to get the next column over? Well, I just multiplied that by 0.10 or just 0.1. Same thing. What did I do to get the 30 gallons? Well, that's constant. So I'm just going to call that 30. And then what did I do to get the 7.5? Same. I mean, I multiplied the 25% times 30 to get 7.5, but that's not changing. So we're going to keep that coming along. Now, the total gallons of chocolate, that was the 7.5 plus this second column here. So in this case, it's 0.1 G. And then the total gallons of the mix, that was the 30 plus the number of gallons that I'm adding. So this is going to be 30 plus G. All right, and now to figure out the percentage, that was, well, look at what we did in this case. We took the 8.5 and divided by the 40. So now I'm going to take this column and divide by the next column over. That is to say, I'm going to take 7.5 plus 0.1 G and divide that by 30 plus G. And I want that to equal 15%, or 0.15. Okay, so now we've got our equation. Now we need to solve. So let me do that. Rewrite the equation, 0.1 G all over 30 plus g, and that I want to equal 0.15. So here's the algebra steps. We multiply both sides by this denominator. Now, to be clear, what we're eventually trying to get is g by itself. Okay, so if I multiply both sides of the equation by that denominator, I'm going to have this. Alright, now let me unlock g from these parentheses, and the way you do that is by distributing over the addition sign, distributing what we're multiplying out here. So 7.5 plus 0.1g, that's going to equal, well, 0.15 times 3 is, plug it into your calculator, but that's 4.5, and then we have 0.15 g. Alright, now I want all my g's on the same side. So I've got more g's on the right. 0.15 is bigger than 0.1, so let's subtract them to the right. That means I'm going to take these 0.1 g's and subtract them from both sides. Alright, that gives me 7.5 plus, well, nothing now, right? Because I subtracted those off. Alright, but I've got 4.5 on the right plus 0.05 g's. Alright, now let's subtract off what doesn't have a g to the other side. So, as I brought my g's to the right, I'm going to bring the non-g's, everything that doesn't have a g, to the left. Alright, and that's going to leave me with, looks like 3 equals 0.05 g. And lastly, to get g by itself, I can divide both sides by 0.05. And if you plug that into your calculator, you will see that 60 equals g. So we would say you need to add 60 gallons of 10% solution to get a 15% chocolate solution. Okay, so if any of that didn't make sense, catch me on Discord. But otherwise, work on some of the problems in groups together. Ask questions on Discord of me, of your classmates, of Ashley, and hopefully we can get through this algebra section unscathed. Good luck, everyone.